Alright, last one is 28 through 31. Basically, it tells you to graph the parent function and the normal. The reason we're doing the parent function is we are using the parent function to create our new equations. Okay? So here we go. So this one is an absolute value. So your parent function is, if that's my x values, 3, 2, 1, 0, 1. Program's being stupid. 1, 2, 3. Okay? And remember everything inside the parentheses. Okay, ask yourself, is it in or is it out? If it's inside, it's x and backwards. Outside is y and normal. Inside x is backwards. Outside y is normal. Okay, so this -2 is inside, so I do it to my x's. And I'm going to add. Because it's opposite. So -3 plus 2 is -1. -2 plus 2 is 0. And I'm just going to go ahead and fill these in. 3, 4, 5. You'll go all the way down. -3 plus 2 is 5. Okay. The plus 3, that is outside. Start off, is it inside or outside? So outside is your positive 3. So we're going to add 3 to the y's. 3 plus 3 is 6. 2 plus 3 is 5. 1 plus 3 is 4. 0 plus 3 is 3. Just lost my mind. 4. And this one mirrors. Alright, absolute values mirror on the other side. So let's plot them both real quick. And again, I want you to use a straight edge for this, but I cannot on a video, so I will do it the best I can. There's a rubber tip on this pencil I'm using, so if I use a straight edge, it's liable to rip. So that's my parent function. -1, 6. 1, 2, 3, 4, 5, 6. -1, 0, 2. Okay, and so that's my new function. Again, I want you to use a straight edge. Cool. 28. Alright, 29. Same idea. If it's inside, do it to your x's and do it backwards. Outside, do it to your y's and normal. Alright, so this is a quadratic. And remember, we don't have to mess with that squared because building the parent function messes with that squared. Okay? So here we go. Inside we have I'm not going to do that. It's a quadratic. So I need to build my function. -3 squared is 9. 4, 1, 0, 1, 4, 9. Those are the points for a quadratic function. Because you simply square all your x's. Remember, that takes care of the square. Okay. Next part. We got to create the new function. We have a negative on the inside. Now, really all that does is flip all the signs, or multiply by -1. There's really no way to do that one the opposite, but we still do it to our x's. So it becomes a +3, a +2, a +1, a 0, a -1, a -2, and a -3. Okay? Now outside we have a 2 and a +1. So we are going to multiply by 2, because that's what the 2 is doing, and add 1. So 9 times 2 is 18, plus 1 is 19. 4 times 2 is 8, plus 1 is 9. 1 times 2 is 2, plus 1 is 3. 0 times 2 is 0, plus 1 is 1. And it's quadratic, so again it mirrors on the other side. Now I know 19 does not fit on the graph. Don't sweat it, just don't plot it. I still want to see it on the table though. Okay? So my original is right. Oh, let's actually get the pencil out, not the eraser. And I've just plotted so many quadratic parent functions, I can almost just visualize it without messing with it. Alright. There's your parent. The next one, 2, 9, 1, 3, 0, 1. And yeah, this may not look reflected, but technically it is. That's your new function. Alright. Cool. I'm going to pause and move to the next one. All right, number 30. Number 30. Okay, again, we're dealing with a quadratic. So we have to build a quadratic function. So again, negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1, 0, 1, 4, 9. All right. And whenever you're dealing with something, first thing you gotta ask. First thing to ask, is it inside or is it outside? All right, so let's do it with the inside. The inside is dividing by 3, because remember, top multiplies, bottom divides. All right, so we are going to, instead of dividing by 3, we're going to multiply by 3. So negative 3 times 3 is negative 9. Negative 2 times 3 is negative 6. Negative 1 times 3 is, well, negative 3. Then 0. Then 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. All the way down. Okay? Outside. Outside is y and normal. So outside, we're going to do it to our y's. So we have a 1/2 and a minus 4. So remember, the 1/2, the bottom divides. So we're going to divide by 2 and subtract 4. So 9 divided by 2 is 4.5. Minus 4 is 0.5. Okay? 4 divided by 2 is 2. Minus 4 is negative 2. Yeah. Just lost my mind for just a second. 1 divided by 2 is 0.5. 0.5 minus 4 is negative 3.5. Okay? 0 divided by 2 is 0. Minus 4 is negative 4. 1 divided by 2 is 0.5. 0.5 minus 4 is negative 3.5. Again, it mirrors anyway, so negative 2, 0.5. Okay? So here we go. Let's go ahead and graph your quadratic real quick. Yes, there's Mr. Hunter's beautiful handiwork yet again. All right, and then the other one, we're at negative 9.5. We are at negative 6, negative 2, 9, 8, 7, 6. We are at negative 3, 2, 3, negative 3.5. Is that right? Yeah. And 0, negative 4. 1, 2, 3, 4, 5, 6. It's negative 2, and 9 is 0.5. So this one is a nice, slow, sweeping arc. That looks like that. Like a big smiley face. Alright, last one, number 31. Alright, so here we go. Inside x is backwards, outside y is normal. So inside, first things first, this is an absolute value. So let's put my y values up there. 3, 2, 1, 0, 1, 2, 3. Okay? Inside, we got a minus 4. So we are going to add 4 to all the x's. Okay? So negative 3 plus 4 is 1. Negative 2 plus 4 is, 2. 3. 0 plus 4 is 4, 5, 6, and 7. Okay? Outside, we have a multiply by negative 2 and an add 1. Multiply by negative 2 and an add 1. So negative 3 times negative 2 is negative 6 plus 1. 3 times negative 2 is negative 6 plus 1 is negative 5. 2 times negative 2 is negative 4 plus 1 is negative 3. 1 times negative 2 is negative 2 plus 1 is negative 1. 0 times anything is 0 plus 1 is 1. And then an absolute value mirrors on the other side. So your absolute value function will look like this. And yes, you have to sing, or you didn't do it correctly. And again, I want you to use a straight edge on this. I just can't. 1, negative 5, 1, 2. Oh, get the right color. 1, 2, 3, 4, 5. 2, negative 3, 3, -1, 4, 1. So it looks like this. Cool. And that's the end of the review. Good luck.